Today we are starting section 3.3 using several transformations. Our objective will be to solve equations by using more than one transformation. Basically that means we're going to have more than one step to get to our answer when we solve these equations. Alright, our warm-ups are still just one step. Natalie, what would you do on number 1 to solve it?
I would divide 4 by both sides.
Good. And what would we get for W? Wonderful. Alright, number 2. Kyan, what would you do? When we see a fraction, we need to multiply by the reciprocal on both sides. The reciprocal of 1/4 is 4 over 1, or just 4. What do we get for x when we multiply by 4? 192. Alright, on number 3. Houston, what would you do? So we multiply both sides by -2. A negative times a negative gives us a positive 10. Number 4 also caused some people some issues. We're trying to make sure that we just have W by itself. Right now we are told the opposite of W equals -10. But I don't want the opposite of W, I just want plain W. Does anyone know what it would be? Positive 10. If the opposite of W is -10, then plain regular positive W would be positive 10. When using several transformations to solve equations, you need to move the number furthest from the variable first. Alright, 2 tips for solving an equation with the variable on one side. The first tip is to simplify each side as needed. Simplify each side of the equation. If the side containing the variable involves a certain order of operations, apply the inverse operations in the opposite order. Alright, let's practice doing that. So I'm still going to box in my variable so that I can focus on it, and split up my equation so I can tell the difference between the two sides. But this time I've got more than one thing going on. Is there anything that I can simplify on the left? Can I take 2x minus 7 and make that any simpler? No. Can I simplify 4? Is there anything to do to 4 to make it any simpler? No, it's just a number. It's just going to be there. So I can't simplify on this one. There's nothing to like combine like terms or anything. So now we are going to start using our inverse operations in the opposite order. Normally, what would come first? Multiplication or subtraction? Multiplication would normally come first. But we are going to do it in the opposite order. So first we are going to deal with the subtraction. So we go backwards from what we were normally doing with our order of operations. So if the first thing I have to handle is the subtraction, Nevaeh, what should I do to both sides? Add how much?
7.
Wonderful. All right, we are going to add 7 to both sides first. That leaves us with 2x equals 11. Notice that my equal sign falls on that line that I used to divide up my problem. All right, Jalen, what would be my next step?
It's not done?
It's not done. I just want x. Remember, I boxed just x in the beginning. So I'm not done until I have just x over here. So if you, what? Okay.
I didn't eat a good breakfast, so I'm lying.
Okay, so let's pretend that this is now our new problem. So I box in my x again. And I keep that line going down. If this is my new problem, what operation's going on between the 2 and the x, Jalen?
Subtraction?
There's not a subtraction sign in between there.
Multiplication.
Multiplication. How do we undo multiplication?
By dividing.
By dividing. So I should divide both sides by 2. So we get x equals, now x is finally all alone. I'm okay if you leave it as 11 over 2, or you can write it as 5.5. Either one of those works for an answer. Now what I don't want is if it gives you some long crazy decimal when you divide that fills up the whole screen of the calculator, I do not want you to round it off. Okay, but since it was just one place after the decimal, then that's fine if you want to put it as a decimal. Alright, let's try another one. Box in my variable, split up my equation. Remember, we go in the opposite order of operations from what we would normally do. Deja, what do you think we should do first?
See if we have like terms.
Good, that's a good thing to check for. Do we have any like terms to combine?
No.
Nope, so we'll move on. Lexi, what do you think we should do?
Add 9.
Very good, we would add 9 to both sides. We have to deal with that subtraction before we deal with the multiplication. When we add 9, we get 5n equals 80. Again, if you want to rebox your variable, so that you can focus on what it is you're doing next, go ahead and do that. You don't have to. Jeriel, what do you think we should do to get n by itself now?
5.
Wonderful. And when we do that, we get n equals 16. Beautiful. All right, on example 3. Box in my variable, split it up. There are no like terms on either side, so I can't simplify them. Jamal Dixon, what would you do next? Alrighty. So that gives us 1/5 x equals 12. Again, rebox your variable if you need to. Jamarl, what would you do next? Multiply by the reciprocal. What's the reciprocal of 1/5? Wonderful. We multiply both sides by 5 over 1 or just 5. It's the same thing as 5 over 1. So we end up with x equals 60. Alright, we are going to jump ahead and do 5 together first real quick before I set you loose on these. This one looks a little bit different. Remember back in chapter 1, long time ago, we talked about the fact that fraction bars work as division symbols, but fraction bars also work as grouping symbols, right? A fraction bar groups the numerator and the denominator separately. So when we see something inside a numerator like that, we have to imagine that there are parentheses around it. So parentheses usually come first when we do order of operations. But now we're doing it in the reverse order, or opposite order. So we want to do parentheses last. Okay, that's why these ones get a little confusing. So I still box in my variable and separate it. But if I want to deal with the parentheses last, I need to deal with the dividing by 2 first. So Ellie, what should I do?
I think that you subtract or add 4 to something. I don't know.
Eventually we will, but I said we gotta save the parentheses for last. How are we going to undo dividing by 2?
You can
Multiply
multiply 2.
by 2. So on these ones, we gotta get rid of that denominator first. So then we have k minus 4 equals 26. Okay, now that there is not a denominator, we can refocus on that variable. And now is when we would add the 4 to both sides. And we would get k equals 30. Okay, so if you see something in a numerator, imagine there are parentheses around it, and that's what's going to have to happen last. So let's jump back to number 4. Does anyone want to raise their hand and tell me how they did this one? Jakeem?
Did the inverse operation.
Okay.
I boxed the variable first. Cut that thing. And use the inverse operation.
Alright, so we subtract 3 from both sides. We have 1/2 x equals 6. Alright, Jakeem, what happened next?
You multiply each side by 2.
Very good, and we get x equals,
12.
there we go. Alright, inverse operation, reverse order of operation. Let's move on to number 6. Anyone want to volunteer to explain this one? Deja?
I did times 9 on both sides,
Good.
and then I got 18 with 2 times 9.
Okay. Then what?
I added 5 to the other side, and I got 23.
Wonderful. W equals 23. So we multiply both sides by 9 first, then we add 5 to both sides. I had a few people ask me about number 7. Normally when we start these, I box in the variable. But on this one, that should be weird because I've got 2. So Keon, what should I do?
Add 2x.
And what would that give me?
5x.
Okay. Now that I only have one variable, I can box it in. And Keon, what would you do to solve this?
Divide by 5 for both sides.
Alright, and we get x equals
8.
8. So always check to see if you can combine like terms or simplify first before you do anything else. Alright, number 8. Any volunteers? Jamal?
We're gonna add 9 or 7A,
And what do we get when we do that?
16A.
32 equals 16a when we add those. And then what would happen next?
Divide 16 on the other side.
Very good. And a equals 2. Wonderful. Combine like terms and then divide on both sides. Alright, on number 9, I'm going to talk through this one because we've got 2 options. So I'll tell you both ways we can go about it. Alright, one way that you might have gone about it was to notice that if we have a number out in front of parentheses, we can distribute. And that is a perfectly acceptable way to go about it. So negative 4 times n is negative 4n. Negative 4 times negative 6 is negative times a negative is a positive 24. So if you did distributive property here, you got to make sure you remember that. Otherwise, it'll mess you up. From here, I hope we all can recognize that we would subtract 24. That gives us negative 4n equals negative 12. And then divide by negative 4. N equals 3. But that's not the only way to do it. If you looked at this and you said, but I see parentheses and parentheses have to go last. Okay, that's fine. So let's redo the problem. Parentheses have to go last. This implies that we are multiplying. To undo multiplication, we would use division. So we divide both sides by that negative 4. That leaves us with n minus 6 is equal to negative 3. And then we add 6 to both sides. We still get that n equals 3. So either way you do that one, you should have ended up with n equals 3. It does not matter to me which way you do it, as long as you show your work and you do it correctly. Alright, let's jump ahead to number 10. Number 10, if you want to save parentheses for last, you got a little bit more work to do. You would have to move the 3 first. So let's just hear from anybody want to volunteer to tell me how they did this? Carl? You what? Okay. All right. Okay. Very good. Then what? Okay. You added 3 to both sides? You can do that. You're just going to cause more work for yourself. Oh, good. I like that better. So we combine like terms to get 8w plus 5 equals 48. Subtract 5 from both sides. Wonderful. And then what do we do? You didn't do the last step? What do we do?
Divide both sides by 8.
Divide both sides by 8. Okay, so that doesn't come out very nice, right? What did we get? 5.375. Yep, you can leave it as 43 over 8 or 5.375. Don't round off your decimal. So if you're using a decimal, you got to give me the whole thing. So I would prefer this top one, but if you gave me the bottom one, it's not wrong. All right. Couple more. We can do it. Number 11. I'm not seeing any new hands, so I'm going back to the sticks. Logan, what did you do next? First, sorry, on number 11. Which terms were alike? And when we add those, what did we get? Wonderful. Combine like terms first. Then, Jakeem, what did you do? Alright. 15r equals 15. Oh, I got my line a little off there. Okay. And finally, Tariana, what would we do? We divide both sides by 15. We get r equals 15 divided by 15.
You asking me?
Yep.
Oh,
1. All right. So far, so good, I hope. Last one. Danielle, you want to tell us what to do?
Yeah.
All right.
I did extruded property.
Okay.
I did 8 times 6, 48. And then 8 times r is 8r.
All right. I like it. Then what?
Subtract 48 from both sides.
Okay.
Then I got 8r equals negative 8.
Okay.
Divide both sides by 8.
I like it.
R equals negative 1.
Beautiful. All right. So we have to either divide off the 8 or distribute it. I like distributing it. Then subtract the 48 from both sides. Divide both sides by 8. We get r equals negative 1.